Okay, we had done some few questions based on circles and tangents. We continue working on the tangents further. In the figure which you see on your screen, AP and AQ are two tangents. AP and AQ are two tangents to a circle with center O. With center O, we have to prove that angle PAQ, the angle PAQ is double of OPQ. OPQ. PAQ is double of OPQ. OPQ. Okay. All right. Now, what are we going to do? There are a few things which we need to use. The tangents drawn, the tangents drawn from from an exterior point to the circle are of equal length. Number one, we'll say AP is equal to AQ. Tangents from an exterior point. From an exterior point. Tangents from an exterior point to a circle are of equal length. So after this, what will happen? So APQ, angle APQ will be equal to angle AQP is equal to X. Let us assume that this is X. This angle is X. This angle is X. It's complete angle. APQ is X. It is X. Why it is X? Because the reason is if two sides of a triangle are equal, angles opposite to them are equal. Now third thing is OP is perpendicular to AP. OQ is perpendicular to AQ. Why? Tangents and radius are perpendicular. Tangents and radius perpendicular to each other. Perpendicular to each other. This is the property of tangent and radius. Radius is always perpendicular to the tangent. So OP is perpendicular to AP and OQ is perpendicular to this. So this angle OPQ, angle OPQ will be equal to 90 minus X, and also angle OQP will be 90 minus X. I'll show it in the figure for your benefit. This angle will be 90 minus X. This angle will be 90 minus X. Why? Because the complete angle APO will be 90. Angle APO will be 90, but one angle APQ is X, so that will be 90 minus X. Now in triangle POQ, what will be angle POQ? Angle POQ will be how much? Will be 180 minus 90 minus X plus 90 minus X. That will come out to be 180 minus 90 cancel plus 2x. This will come out to be 2x. POQ will come out to be, PAQ will be 180 minus, POQ is 180 minus whatever I to calculate. We have to prove that PAQ will be 180 minus 2x, and we have to prove 2 OPQ. Sorry, I don't have to calculate POQ. I have to calculate PAQ. I have to calculate PAQ because I don't need that. Sorry. Angle PAQ will be 180 minus 2x. Why? This is x, this is x. So the remaining angle PAQ will be 180 minus 2x. And OPQ is how much? 90 minus x. So PAQ is double of OQP. Double of OPQ or O. Double of OPQ also. Double of OPQ also. PAQ is how much? 180 minus 2x. And this is how much? 2 into 90 minus x, which is also 180 minus 2x. That is why this statement will happen. So we are using the property, the length of tangent is same. If the length of tangent is same, then in triangle APQ, AP is equal to AQ. If AP and AQ are equal, then the base angles of the triangle, because it will become an isosceles triangle, and base angles of isosceles triangle are equal. So x and x, and angle OPQ will be equal to angle OQP will be 90 minus x, because the tangent and radius are perpendicular to each other. And we calculated angle PAQ to be 180 minus 2x, and we realized that this angle PAQ is double of OPQ, which is 90 minus x, but this is 180 minus 2x. So the relation is that PAQ is double of OPQ. This is question number 9. Now let us see question number 10. What is question number 10? Let us see. He has shown you a right angle triangle whose one side AB is 12 centimeter, AC is 13 centimeter. So we can easily calculate BC. We can easily calculate BC by applying Pythagoras theorem. Whenever right angle triangle is given, you will have to apply Pythagoras theorem. Then another thing is that a circle is inscribed in this triangle. A circle is inscribed in this triangle, and the radius of that circle is x centimeter. We have to find the radius x. Now, first of all, I'll apply Pythagoras theorem to triangle ABC. In triangle ABC, I will say BC square will be 13 square minus 12 square. That will be 169 minus 144. BC will come out to be under root 25. That will be 5. It will be always positive. It modulus. The square root is always positive. It is modulus of, whenever we take a square root, we take the modulus. So we got this as 5. We got this as 5. Now, second thing is that please notice in this figure, this is O. OQBR. In OQBR, OQ is equal to OR is equal to RB is equal to QB is equal to X. If this is X, this is also X. Why? Because it is a square. All sides are equal, all angles are 90 degree, and if two sides are equal here, OR is equal to OQ, then QB will be equal to BR also. It is a square. It is a square. Now the question is that this AB is given how much? 12. AB is 12. So AQ will be equal to AP. AQ will be equal to AP will be equal to 12 minus X. because this length was how much? This complete length AB was 12. So AQ will be how much? 12 minus x. And if it is 12 minus x, then AP will be also 12 minus x. Tangents are of equal length. Tangents. Tangents drawn from a point, exterior point to a circle are of equal length. Now, fourth point will be CR will be equal to CP will be equal to 5 minus x. Why? Because the total BC was 5 and this is x, so CR will be 5 minus x, so CP will be also 5 minus x. The same reason, tangents. It is tangents are of equal length. This is how much? 5 minus x. This is also 5 minus x. Now AC is equal to what? AP plus PC. AP plus PC. AP is how much? 12 minus x. PC is how much? 5 minus x. And AC is how much? 13. Complete length is 13. We know AC is 13. So 12 plus 5, 17 minus 2x is equal to 13. Minus 2x will be minus 4. 13 minus 17 will be minus 4, or x will be equal to 2 centimeter. That is the radius of the circle. That is the radius of the circle. What we have used, again the same properties. Two main properties have been used. Number one, tangents drawn from an exterior point to a circle are of equal length. We said AQ will be equal to AP. These are tangent because when a line is touching a circle at a point, it is tangent. So AQ and AP are equal, which are each 12 minus x. CR is equal to CP, each is 5 minus x. And because y minus x, because QB is equal to BR is equal to x, because the figure OQBR is a square, a square. All angles are 90 degree. This is 90 because this is radius is always perpendicular to tangent. It is also 90 degree. This is 90. That the fourth angle will be also 90. So this figure OQBR or ORBQ is a square and each side is x centimeter. So using that property, we have found AC to be 12 minus x plus 5 minus x. But AC was given equal to 13 centimeter. So 12 minus x plus 5 minus x will become equal to 13. That gives us 17 minus 2x is equal to 13, or minus 2x is equal to minus 4, or x is equal to 2 centimeter, or x is equal to 2 centimeter. Okay, now let us see the next question. It is also again a question based on tangents. He says PQ and PR are tangents to a circle with center O. PQ and PR are tangent, that means the radius and tangent will be perpendicular to each other. That means this angle and this angle will be 90 degrees. This will be 90, this will be 90. And it is given that QPR is 60 degree. QPR is 60 degree. So I can find first of all QOR. First thing, angle OQP is equal to angle ORP is equal to 90 degree. Tangent perpendicular to radius. Tangent and radius are perpendicular to each other. Tangent and radius are perpendicular to each other. Now angle QOR will be 360 degree minus 90 plus 90 plus 60. Why? The sum of interior angles of a quadrilateral The sum of interior angles of a quadrilateral are equal to 360 degree. Three angles are known, so to calculate the fourth angle, I will subtract the sum of the three from 360, 90, 96, 180, 180, 60 is 240. It will come out to be 120. It will come out to be angle QOR will come out to be 120 degree. This angle will come out to be 120 degree. Now he wants next angle is I can calculate QSR, that last angle. First I'll calculate QSR. QSR will be half of angle QOR. Angle subtended by an arc at the center. Angle subtended by an arc at the center. Which is the arc which we are using here? Is this, which I am showing in yellow. This arc subtends angle QOR at the center, and the same arc subtends angle QSR at the circumference. So the relation is that angle QSR will be half of this, will be half of 120, so it will be 60 degree. Double angle property. Double angle property. Double angle property. This is double angle property. Now we have to find angle OQR. OQR. I have to join Q to R. Let me join it. Okay, let me take another color for it. Black color. Okay. He wants angle OQR. OQR. Okay. In triangle OQR. In triangle OQR. OQ is equal to OR. OQ is equal to OR radii. These are the radius of the circle. So angle OQR will be equal to ORQ. Angle OQR will be equal to angle ORQ. It will be 180 minus 120 upon 2. Why 180? Because this angle is at the center, QOR is 120, and the remaining two angles are going to be equal. OQR is equal to ORQ. So 180 minus 120 is 60. 60 divided by 2 is 30. 60 by 2 is 30 degree. So we have got all the four angles. What are the angles which we wanted? QOR. We wanted QOR. We got this angle QOR. We wanted angle QSR. We got this angle, and we wanted this angle. We got this angle. So we have got all the three angles what we required. Okay. Now let's see the next question. Again a tangent question. It says PT is tangent at R. SQ is diameter produced meets tangent at P, given that angle SPR is X, angle QRP is Y. First angle we have to find, we have to prove ORS. Angle ORS is Y degree. I would say that angle QSR will be equal to angle PRQ will be equal to Y degree. This will be also Y degree. Why? Angle between a tangent and chord. PT is a tangent. PT is a tangent and QR is a chord. So angle between the tangent PT, angle between PT tangent and RQ chord is equal to angle in alternate segment. In alternate segment, this is the theorem which we have done. Alternate segment, the angle between this and this will be equal to in the alternate segment. It will be equal to the angle in the alternate segment. This is, if this is y, this is going to be y. If this is y, this will be y also. Why? Because OS is equal to OR in triangle ORS. In triangle ORS. In triangle ORS, ORS is equal to OSR is equal to Y. OS is equal to OR. OS is equal to OR. OS is equal to OR. OS is equal to sorry. OS is equal to OR. So that becomes Y. That is the reason we have used the property angle between tangent and chord is equal to the angle in the alternate segment. We can use many other properties for finding out, but this is a direct method which we were able to get. Now he said write an expression connecting this and this. Now this angle could be x plus y. Angle SQR, angle SQR is x plus y. Exterior angle of a triangle. Exterior angle of a triangle is equal to the sum of the interior opposite angles. Exterior angle of a triangle is equal to the sum of the interior opposite angle. In the triangle PQR, just see the triangle PQR, angle P is x, angle R is given y, the exterior angle will be x plus y. This angle in the triangle QRS is y, and angle QRS will be 90. Angle QRS is 90, angle in a semicircle, in a semicircle. Angle in a semicircle. Angle in a semicircle is always a right angle. Angle in a semicircle is a right angle. So I have got angle Q as x plus y, angle S as y, and angle R as 90. Now I will add up all the three angles and its sum should come out to be 180. X plus y plus y, x plus y plus y plus 90 should be equal to 180 degree. Sum of the interior angles of a triangle is always equal to two right angles. This is in triangle QRS, in triangle QRS. So x plus 2y is equal to 90, and this is the relation between, this is the relation how x and y are related. This is how x and y are related. That is what he said, write an expression connecting x and y. So we have connected x and y with the relation x plus y is 2y is equal to 90. So that finishes this complete exercise on the tangent. I have done a lot of questions on tangent So you should go through all the questions, and if you have a problem, then you can always discuss it with us. But I have done quite a few, and I next set will be about